Welcome to this video on cementing extraterrestrial space. So in this video, we will see information and we will discuss information regarding construction activities that would take place outside the Earth. That's why the word extraterrestrial, it's outside Earth. And this is a small introduction about me. And here we have to the right an astronaut saying you hello before we begin this video. And this is the general outline of this video, and as well as a couple of videos that are that will follow this particular video. So this is one of the this is the first video in the series, and in these videos, in this video series, we will discuss about construction activities in outer space. So first we'll discuss a little background on what is space construction all about and why we do it. And next we'll discuss about some of the challenges that exist and possible solutions to solve those, to tackle those challenges, and what type of techniques of construction that we can use and that people are thinking to use it, and what materials make it possible for construction to take place. And also we'll discuss very recent developments with respect to the material research part, considering some material simulants, and also we'll discuss something about ISRU, which is in situ resource utilization. So that is all to do with using resources that exist right there in the space. And also we'll discuss some latest developments with respect to cement based materials for space construction. And finally we'll wrap this video series by discussing the way ahead or the future of this research or the program. And onto the right here, you can see an architectural design or an architectural view of how the construction constructed units would look like. So basically, this is one of the examples for modular construction that that is planned to be done in the space. So where we basically have like modules, different modules. For example, that I number here 1, 2, 3, 4, 5 modules are shown in this picture. So you have these modules, module 1, module 2, module 3, and so on. They are made separately and they are connected, joined together so as to act as one unit. So that's a typical example of modular construction. And this picture is an architectural imagination or an architectural rendering of how the units would look like in space. So we'll discuss a little bit about the background. So what is this all about and why we need space construction, and what it is. So we know all the research that humans do, it is all to improve the human life, right, in on one or the other way. So and this type of research is not restricted only to Earth but also in the outer space. And when we talk about when we mention outer space, especially in this video and the video series, it's mainly to do with constructing structures on the surface of Mars or on the surface of Moon. So Moon, it's also called lunar, right? So whenever you come across this word outer space in this video series, that has more to do with construction on Mars and Moon. So yeah, so we know that this research is not restricted only to Earth, and when we talk about outer space, we can see a lot of challenges with respect to distance, with respect to transporting materials, with respect to the money that is involved in the venture. So for example, how distance can be a problem. So here I have given two examples. So the distance from Earth to Moon is almost 380 k kilometers, so which is almost close to 30 times the Earth, 30 times the size of the Earth itself. And distance from Earth to Mars is almost about 55 million kilometers. So basically the distance is way too larger for anything to be transported, be it humans, astronauts that go there, the transportation associated with astronaut travel and shifting any material from Earth to space and so on. So the transportation will be very, very difficult, and obviously that is why this makes it the space program an expensive venture. So why this is relevant? Why constructing in space is relevant? Well, we want to have some safe permanent base in outer space, that is on the surface of Moon and Mars, as already mentioned earlier. And also we want to protect humans being astronauts here. We want to protect astronauts and also high expensive research equipment they use in outer space. So by building permanent structure, we want to protect humans and equipment. And also this having a permanent base helps astronauts to stay for a long time in the outer space safely. And also for all the types of research that is being done in the space, such as with respect to solar power generation or any educational research or research related to solar system exploration and so on, can also be supported due to this. And when we in the point number 2 here, when we discussed about protecting humans and equipment, so what we are protecting these from? So well, so three primary factors are given here in the bottom pictures. One is the extreme temperature. We want to protect them from extreme temperature. So we'll see what exactly the numbers are in the next slide. And we want to protect them from the dust storms. Dust storm, especially on the surface of Mars. And also there is a very common problem that is associated with meteorites falling from outer space into these bombarding on these research equipment, and also it can be deadly to humans. So what can be the viable solution? Yes, for construction to happen, we can use concrete and ceramics mostly. We can use for construction in space, and other construction that can be related to steel construction, timber, or others can be difficult, because steel and timber have to be transported from Earth, and it makes it very impractical because it's very expensive, as already discussed earlier. So for example, to transport 1 pound, 1 pound is 0.45 kilograms, 1 pound of any material from Earth to space. So it costs almost 10,000 US dollars. So it's highly expensive for any transportation to make. So basically we want to have any material that is already existing in space instead of shifting them from Earth to space. So then how will we do concrete and other materials, similar materials such as ceramics in space? Well, for a material for a to prepare concrete, we have some materials that are already available in space, such as for example shown in these two pictures here. So typical concrete consists of stone that we call fine aggregate and coarse aggregate, and we need water for hydration, and also we need some binder which can bind the overall system, right? So water is an important component, and such water is already believed to be or proven to exist in outer space. For example, the picture here on the left shows a mapped water source in the poles, near to the poles, and you can see these blue colored regions show that existence of water. And the color scale on the to your left here shows that the blue colored region, the temperature there is minus 200 degrees Celsius. That means to say that water is there, but it is in frozen state, so it's not readily available for us to use. And on the other hand, we also have something called regolith, which is a rocky, loose, powdery material. So it similar to dust, which can be used for making concrete. And the possibility of making concrete and ceramics is already well researched from you can see the reference I've given here at the bottom. Even in the days in 19 even in back in 1992. So people have been thinking about space construction since then, and even before that, to be honest. And for this, after knowing what are the viable solutions, so especially for making concrete, right? That's a viable solution. But what are the related challenges? Well, the materials that we saw, like water and regolith, they are kind of like different from those materials that exist on earth, and also their properties are not fully known, and also we do not know how those materials are going to perform by themselves and also when used in concrete. And also one more biggest challenge is that the pressure in the space, in outer space, there is very low pressure, which is almost close to 0.06 bar, 0.006 bars, which is very very low pressure, this which can result in water to leave the concrete. So well, we know water is very important for hydration reaction to take place. So basically no water can be used in space because water will leave or evaporate from concrete due to low pressure. And also the temperature in outer space can fluctuate from minus 170 degrees C to almost positive 170 degrees C. It's a very huge range and fluctuation of temperature which can be deteriorating to the concrete structure, and it will damage the concrete. And also we cannot ignore the fact that the gravity is very very low in outer space. For example, on the surface of moon, the gravity is 0.17 times the gravity on earth, and on the surface of Mars, that is Martian, so the Martian gravity is 0.38 times that on the surface of the earth. So basically the gravity is very low. This can be challenging as well. So yes, so till now we discussed why we need to construct structures in space, and what are the challenges and what are the viable solutions. And with this we will end this today's video, and in the next video we will see possible construction techniques and something about material research that people are working on in order to make this space venture easier or viable. Thank you very much for watching this video, and please do not forget to like, share and subscribe to the channel, to my channel, that's Learning Corridor.